Let's suppose you are given this kind of problem on the SAT subject physics test. You are given a plot of the velocity versus time, and you are asked to find a plot of the momentum versus time. Now, before we actually get into this, let's just analyze a bit this graph here. From moment 0 up to moment t sub 1, the graph is a line, so this one here is a straight line. Now, from t sub 1 up to t sub 2, the velocity is a parabola section. Now, I've drawn the entire parabola here just so you can see it. However, this dotted line does not take part in our phenomenon here. It's not part of the graph. Now, how do we choose from these options the right one? Well, we take advantage of the formula P equals m times v, which is a formula we all know. So, for t between 0 and t sub 1, we have the velocity equal to a constant k times t sub 1, times t actually. So why is this? This is because the line is straight, so this is a straight line which goes through the origin, and this is the formula for such a graph. Now, this means that if we take this one and plug it here, we will get actually a formula for the momentum for this time interval right here. So, if we just go ahead and write P equals m times k times t. Now, m times k is actually a constant, so this right here is a constant multiplied by t, which is again a straight line going through the origin of our system. So, we can just look at these options here and reject the ones who don't meet such a property. So, option A shows a graph, a horizontal line which is parallel to the OX axis, and so it doesn't go through the origin even though it's a straight line, and so this one is false. Now, option B. Now, this one here is a curved line, so it's not straight, and this one also cancels. This one is false because it's not a straight line going through the origin. Now, option C. If we look here, we will see that it is indeed a straight line going through the origin, so this one is okay. I'm not going to rule out this one just yet. Now, option D. We have a graph. This is kind of an interesting graph. So it's a curved line which goes through the origin, so it's not a straight line. This one is false. Remember, we are looking for, I'm just going to write here, we are looking for a straight line going through the origin. So that's what we are looking for, simply because of this equation right here. Now, A, B, and D do not actually meet this property, so we cancel them. And now, option E. Well, it is indeed a straight line which goes through the origin, so that one, as far as we're concerned at the moment, is also okay. So now we are left with two options. So which one of these is actually right? Well, if you look at the graph from option E, you will see that it's kind of weird, because you can see it has a gap. I mean, this line here stops at this point, and then the graph restarts here, and so it has a gap, which is kind of weird. Now, if we look at the velocity graph, we will see that it's continuous. Continuous means that it has no gaps, and so if the velocity is continuous and p is actually a constant multiplied by velocity, then the graph of p should also be continuous. And so this graph here, since it is not continuous, it's false. So yeah, I'm just gonna write here again, the graph has to be continuous. continuous. So since this one has a gap, we have to rule it out. Now, the reason, yeah. So we are left with this option C right here as being the right answer. So I'm just going to write here C is right. Now just going back to this option E. This graph here of the velocity versus time does not have any gaps again. So yeah, well, you can get it. It's not okay this because it has a gap, and this one right here doesn't have a gap. So yeah, this one rules out. So we are left with option C. Well, now just so that we verify ourselves, I'm just going to compute the equation for this bit of graph right here, this one, from here to here. Now, actually this is for, excuse me, well, it's kind of embarrassing. For t between t1 and t2, we have v equals, and now this this equation right here, it's well, if you remember your math stuff, this is equal to t minus t sub 2 squared. And now p is m times t minus t sub 2 squared, which is just the parabola here multiplied by m. And so even though it's multiplied by m, because m is a scalar, it would look basically the same. I mean, just remember that these graphs are not like super accurate or anything like this. They're simply just drawn, and you just have to pick the one which is closest to your calculations. So even though this one might look like, I don't know, it's steeper than this one or shallower than this one, it just doesn't really matter. You're just picking the one which is closest to what this one is, to what your calculations are. Yeah, it's not intended for it to be 100% accurate. However, the shape of the graph is indeed accurate. So yeah, that's how you solve this problem. And you have to remember that come exam day, you will actually need to do all of this in your head. It's like realizing that P is m times V and just doing this bit here, in your head, and then just selecting the graphs which do not match the predicted results. And so you have to do all of this in about 10 seconds. This is one of the problems which you must take advantage of, because it can be done very fast, and thus it can give you more time on more difficult problems. So if you do this under 10 seconds, it's great. It's absolutely great. So yeah. That's it for today. See you next time. Bye bye.